Good morning, students. I hope you all are well. We are doing linear algebra. In last two videos, we have revised some basic concepts like algebraic structure, binary composition. Binary composition is of two types. One is called internal binary composition and other is called external binary composition. If we have algebraic structure, then this algebraic structure includes one set and one binary composition, one set and more than one binary composition, or two sets and more than one respective binary compositions. We are doing linear algebra, and linear algebra is the study of vector space. Yesterday I explained vector space is a special type of algebraic structure. In this algebraic structure, we have two types of binary composition. One is internal binary composition and other is external binary composition. So let us continue. Let G be a non-empty set equipped with a binary composition denoted by this one. G is a non-empty set. Means it must have at least one member. So let G be a non-empty set equipped with a binary composition denoted by this symbol. Therefore, that means is an algebraic structure. This one is known as algebraic structure. Remember, if I write this is an algebraic structure, it means G is a set and here it is non-empty set equipped with a single binary composition. That means there exists a mapping such that for all A comma B belongs to A implies consider any two members. This implies A as B must be A. Taking two elements at a time, and whatever the composition is given, you just apply on that. The answer must be in given set. Then you see the binary composition. So this G is with binary composition, then this is called the algebraic structure. Now this algebraic structure, that means is Yesterday I told algebraic structure satisfying some properties, then according to the property we will change the name of the given set in which the binary composition holds. So this algebraic structure is called semigroup. If G has associative property, that means this binary composition is associative. Similarly, is called monoid. If G has associative property and there exists E belongs to C such that for all A belongs to C, A asterisk E equals to E asterisk A equals to A. That means identity exists. This was also explained yesterday. The example was given. So if you are not able to understand whatever I am writing here, then you go through the previous video, revise them again and again. Okay, so this algebraic structure is called semigroup. If associative property holds, this is called monoid. If G has associative property and there exists an element in C in such a way that A asterisk E equals to E asterisk A equals to A. That means if semigroup has identity element, then semigroup is known as monoid. Okay, so this algebraic structure is monoid if it has associative property and there exists an identity element. Third, if J means this algebraic structure satisfies the following properties, then J is called group. What are they? Number one, associative. Number two, existence of identity elements. Number three, of every A belongs to C, there exists the inverse belongs to C such that means every element has its inverse. What is this? Algebraic structure. Why is it algebraic structure? Because for all sometimes you say it is closure property. This is the closure property. Due to this property, this one is called algebraic structure. So this algebraic structure is known as semigroup. If this operation is associative, this is monoid. If this is associative and identity elements, both left and right, exist. This algebraic structure is known as semigroup if this is associative. Monoid, associative as well as identity element exist. Group if this is associative identity element exists and every element of Z has its inverse, both. That means left inverse as well as right inverse. This part is given in abstract algebra. So G is a group if it has closure property, associative property, identity element and inverse. Abelian group J is a group. If J is a group, means it has four properties: closeness, associativity, identity and inverse. So this is a group. It is called an abelian group. If it has commutative property or this operation is commutative. Okay, so this is a group. It is called an abelian group if it has commutative property. क्रम विनिमेयता जिसको हिंदी में बोलते हैं, एसोसिएटिव साहचर्यता, आइडेंटिटी एलिमेंट, तत्समक अवयव, इनवर्स प्रतिलोम अवयव, कम्यूटेटिविटी, क्रम विनिमेयता. ओके, G is an algebraic structure. Single binary composition, remember. This is semi-group. This is monoid. This is group. Further, it is abelian. This algebraic structure is known as semi-group. Then what will happen? This is monoid. Then what will happen? This is a group. Then what will happen? And this is an abelian group. Then what will happen? So this you have to remember in your mind in basic concepts. Okay, so what is this? Now suppose G is equipped with two binary compositions. One is this and other is this, denoted by these two symbols. Algebraic structure. G cross G to G. And this diamond symbol, again it is G cross G to G. Internal binary composition. Remember, internal binary composition. So how many binary composition? Two binary composition. I continue this. I am talking about this. First, this is an abelian group with respect to this binary composition. This is G is known as abelian group with respect to this particular one. It means it has 5 properties: closure, associativity, identity, inverse, and commutative property. Second, is associative or has associative property. Remember, this has 5 properties. That's why it is abelian group. The word itself indicates it satisfies 5 properties. This binary operation, the second one, is associative, or this has associative property. Remember, this is binary composition, so definitely it is closed with respect to this. Means closure property with associative property. Third, how many properties it has? 5, due to this one, abelian. How many here? 2. Closeness and associative property. Third, I write the interconnection between this one and this one, these two binary composition. That is here distributive property. Means let's A, B, C belongs to C, then A asterisk it is this. You can understand by replacing star by plus and this diamond by multiplication. So, if star indicates plus sign and diamond indicates dot, then A dot B plus C equals to A dot B plus A dot C. Multiplication over addition. This algebraic structure has 2 binary compositions. One is denoted by this symbol, other is denoted by this symbol. You can use plus sign for this, you can use dot sign for this. That means multiplication. So, if it is algebraic structure with 2 binary compositions, then we have these 2 things. Be careful. If this is abelian group, who is abelian? Z. G is abelian. What is Z? Non-empty set. Be careful. Non-empty set. Z. Equipped with 2 binary composition denoted by these 2 symbols. Means this is closed. It is also closed. What do you mean by closed? Means A asterisk B belongs to C. This is also closed, means A belongs to C. For all A comma B belongs to C. Example, set of natural numbers. Now listen, lower classes. In lower classes, we do not describe all the things. हेडेक हो जाएगा, सिर भारी हो जाएगा, समझ में नहीं आएगा. But that time we people know that addition of any two natural numbers is a natural number. So addition is closed in set of natural numbers. Multiplication of two natural numbers is again a natural number. So multiplication is closed. So this is the algebraic structure defined in set of natural numbers. Addition is closed in n, multiplication is closed in n. Now my question is addition here is n a semigroup? Here it is. This is an algebraic structure. This algebraic structure is a semigroup if it satisfies associative property. 100% the numbers follow the associative property. Numbers, I mean to say natural numbers, integers, rational numbers, real numbers, complex numbers. I am specific with that, standard sets. So numbers follow the associative property. So this structure with respect to plus is a semigroup. With respect to plus, is it monoid? The set Z is monoid if it is associative and identity element exists. Remember here the operation is plus and 0 is that number which is added to any number. The answer is the number itself. So 0 has this type of property, but unfortunately 0 is not the member of n. This is not the natural number. So n with this operation is not a monoid. It is not definitely a group. So n with plus is only the semigroup. Be careful. Okay. Now we come to this dot multiplication. Definitely multiplication is associative. So associative multiplication is associative. That means this n is a semigroup with respect to these two binary compositions. Okay, so it is that type of situation. see, algebraic structure equipped with two binary composition denoted by plus and dot. Means it is this. With respect to plus, abelian group. With respect to multiplication, two things only, that is closeness. Generally it is not written, but this has associative property, and one more property that connects between these two operations. Here it is, that is distributive property. If G has all the things, then G is called ring. So what is the ring? Ring is an algebraic structure equipped with two binary composition. With respect to first binary composition, that is denoted by plus, generally we say addition. It is a abelian group. With respect to multiplication, associativity holds, and one more property that connects this and this one, that is called distributive property. So if G equipped with these two binary compositions satisfying these properties, then G is called ring. Okay, now I increase the properties here. First, G is an abelian group. It is better to write like this. Second, abelian group with respect to and third, as usual, distributive property. Then G is called a field. What? Five plus 5, 10 plus 1, 11. Then this algebraic structure, that means the set G, is called field. So a non-empty set G equipped with two binary composition is known as field if it satisfies 11 properties. 5 abelian group with respect to addition, 5 abelian group with respect to multiplication, and one more property that connects plus and dot. Okay, so today little bit introduction about the group, ring and the field. I am not teaching you the abstract algebra, I am teaching you linear algebra. And in linear algebra, because linear algebra is the study of vector space, and vector space is a special type of algebraic structure. So first I have introduced what is the algebraic structure, and if this algebraic structure satisfies some properties, then what will be the particular name of that algebraic structure. So the name of the algebraic structure we have defined here, that is the group, ring and the field. Today it is enough. Try to understand whatever I taught. If you have difficulty, you write the comments in comment box and try to revise all the things. Thank you very much.